Hello, let me introduce myself. My name is Jose Nicolas Rodriguez Velasco, and now I come to present to you extra atmospheric masses of the Canadian Bolides. Today I'm going to talk about a fascinating topic in space physics, the extra atmospheric masses of Bolides, based on a study by N.A. Gritsevich and V.P. Stulov from 2006. This research from the Institute of Mechanics at Moscow State University focused on analyzing Bolides recorded by the Canadian Meteor Network. First, what is a Bolide? A Bolide is a bright fireball tied apart when a meteorite enters Earth's atmosphere and burns due to heat and friction. The main goal of this study was to determine the original mass of these bodies before entering the atmosphere, known as the extra-atmospheric mass. Scientists used to estimate this mass using the photometric formula, which measures the brightness of the meteor along its path. But there was a big issue. The result from brightness didn't match the values calculated from deceleration and motion. In most cases, the photometric mass was much larger than the true one. To solve this, the researchers studied data from Canadian Bolides, analyzing their speed, altitude, and how they slowed down in the atmosphere. They found that the photometric method was exaggerated because meteorites often break into many fragments. These fragments together produce much more light than a single object would, but they behave aerodynamically as one. That's why brightness does not truly represent the mass. So they propose it using physical equation of drag and amplitude instead of luminosity to calculate its true mass. With this new approach, they obtained more accurate and realistic results. They analyzed for main bolides and compared the results. For instance, some meters that seemed to weigh over 1,000 kilograms by light estimates actually had only 5 to 300 of real entry mass. This showed that the traditional method overestimate mass be up to 10 times. They also studied critical altitudes where the meteor starts glowing or form a shock wave to understand how air resistance and energy change during entry. In conclusion, the study proved that the photometric method is not reliable for large bodies. A better way is to focus on their deceleration and fragmentation in the atmosphere. These findings help scientists predict impacts more accurately and understand how meteorites lose mass as they travel toward Earth. This research was an important step toward improving how we study and model meteor entries. Thank you for listening.